A solid is obtained by revolving the shaded region about the x-axis. So we want to take this shaded region and rotate it about the x-axis. That's going to put the curve down here. And then when we rotate it, we get this solid shape. Looks something like a bell. Then if we take one slice out of the middle, notice that we're getting a disc shape. So to create the volume now, we'll take the integral from 0 to 3, and then we want to take the area of one of those slices. Notice that slice is a circle. We're going to take the area of that slice. Each one of these slices will stack on top of each other, creating the solid. We now have the integral from 0 to 3. Notice that each slice is a circle. The formula for the area of a circle is pi r squared. So we have pi and then r squared. Notice that r, the radius, is this distance here, which is going up to the curve, which we are told is x squared plus 5. That's our radius. If we simplify this, we get v equals the integral from 0 to 3 pi x to the 4th plus 10x squared plus 25 dx. Now we want to evaluate this integral to find the volume of the solid. So we'll leave pi on the outside, and integrating we get 1/5 x to the 5th plus 10/3 x cubed plus 25x. And we are evaluating from 0 to 3. Now we plug in our limits. Start by plugging in the upper limit. Every time you see an x, we'll just plug in 3. And then we need to also plug in the lower limit. We'll need an extra set of brackets here. 1/5, plug in 0. Plus 10/3, 0 cubed, plus 25 times 0. Simplifying this, we'll just throw this into the calculator. We'll get 213.6 minus 0, leaving us with 213.6 pi. A solid is obtained by revolving the shaded region about the y-axis. So this time we are revolving around the y-axis. That's going to push this curve over here. So we have something like this. And when we revolve around the y-axis, we get a bell shape. So each slice that we take out of this solid is going to be a disc or a circle. The volume is in the integral from 1 to 9 and this time the area is a function of y dy. Integral from 1 to 9. Again, each slice is a circle, so the area is pi r squared. And in this case, the radius is created by this curve here, y equals x cubed plus 1. But since our variable is in terms of y, we need to isolate this and solve for x and have x in terms of y. So we subtract 1 and then take the cubed root. And we now have x in terms of y. That's our radius. The cubed root of y minus 1. And then we have dy on the end. We can simplify this a tiny bit. This will be the integral from 1 to 9 of pi times y minus 1 to the 2/3 power dy. Up next, we'll evaluate this integral to find the volume of the solid. In order to integrate this, we're going to need a u substitution. So let's let u be y minus 1. Then du will be 1 dy. Now we can rewrite this integral. We have the integral of pi times u to the 2/3 du. And remember, we need to change our limits of integration since we changed our variable. So earlier we had 1 as a lower limit, so plug in 1. Our lower limit is now 0. Our upper limit used to be 9. Plug in 9, we have 9 minus 1. Our upper limit is now 8. Continuing to integrate, we have pi times 3/5 u raised to the 5/3, and we want to integrate from 0 to 8. Now we plug in our upper limit, 3/5 times 8 raised to the 5/3, minus, plug in the lower limit, 3/5 times 0 to the 5/3, simplifying this, we have pi times 19.2 minus 0. That gives us 19.2 pi. And that is the volume of the solid.